Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. So today in this video, we are going to see about top 5 scenario-based JMeter interview questions that might be asked during your interview. So the very first question or the very first scenario that we see here is based on an e-commerce website. So the interviewer will give you a scenario where you will be asked to test the performance of an e-commerce website during a sale event. So this is something like during the Black Friday or during an event like a Thanksgiving Day. So the interviewer might want you to test the performance of the website during the peak sales. So the expected user load is 10,000 concurrent users, and you want to know that how would you design a load testing scenario using JMeter, and what are all the elements would you include in your test plan to simulate the realistic user behavior such as browsing products, adding them to the cart and checking out. So these are some of the scenarios that he gives you, that these should be part of the plan, like browsing the products, adding them to the cart and checking out. So now let's see what is going to be your answer, or how should you explain this scenario to your interviewer so that he very well understands and he makes, and that makes you to, that makes the interviewer to know that you are having knowledge on JMeter. So before we move on to the video, this is me, Vasan Shanmugam. I welcome you all to Little's Law YouTube channel. Please don't forget to subscribe to our channel if you have not subscribed yet. Like, share the video and comment your questions or feedback in the comment section. So now let's go to the answer. So how will you handle this scenario? So the very first point is, the very critical thing is the test planning design. So the test plan design, so you'll have to start by creating a well structured test plan in JMeter. And how will you do that is, the first part is the thread group. So you have to set up a thread group to represent the simulated users, and you have to define the number of threads, that is the number of users, and ramp up time, so how quickly users should be added to the testing. And the second part is the HTTP request. So you have to add HTTP sampler elements to simulate user actions such as browsing products, adding them to the cart and checking out. So these are some of the scenarios that he gave you in the scenario question. So you have to tell them that these are the user actions that will be covered, that is the browsing products, adding them to the cart and checking out. So each HTTP sampler represents a specific page or action. And then coming back to the second point, which is realistic user behavior simulation. To simulate a realistic user behavior, we have to follow few steps. The first thing is browsing products. So here in the scenario that he gave, so he gave us a hint like what are the scenarios that we have to add. So we have to add the browsing product. So we have to create a HTTP sampler for browsing the product categories, and we have to use a loop controller to simulate multiple page views within a session. And then we have to add the next scenario, which is adding to the cart. So after browsing, users add products to the cart, and they have to use a different HTTP sampler to simulate adding products to the cart. And then cart management, so we have to simulate viewing and modifying the cart contents using relevant HTTP samplers. And then the last scenario, which is the checkout process, so we have to model the checkout process using multiple HTTP samplers for entering shipping details, selecting payment methods and confirming the order. And then coming back to the third point, which is the think time and pacing. So when we introduce think time between user actions to mimic real user spacing, think time represents the time a user spends on a page before moving to the next action. And we have to use timers like constant timer to insert the think time. So we have to tell all these things to the interviewer to make him understand that we have knowledge, we have hands-on experience in using JMeter. And then coming back to the fourth point, which is the parameterization and data variation. So we have to parameters dynamic values like product IDs, the user credentials, and payment details, and we have to use CSV dataset config to feed different data to users, making the simulation more diverse and realistic. Then coming back to the fifth point, which is assertion and response verification. So we have to add assertions to validate responses. For instance, we have to check if the product details page runs expected content. So assertion helps us to identify for any discrepancies between expected and actual behavior. And now coming back to the load distribution, which is the sixth factor in this scenario, which is the load distribution. So depending on our test environment, we have to distribute the load across multiple machines using JMeter's distributed testing feature. And this helps simulate a higher number of users than a single machine can handle. Then coming back to the seventh point, which is ramp up and load pattern. So we have to set up a realistic ramp up pattern for the thread group to gradually increase user load, and during a sale event users might start visiting the site more rapidly as the event begins. And then coming back to the eighth point, which is the result collection and analysis. So we have to configure JMeter to save the test results, including response times, their throughput, and the error rates. And after the test, we have to analyze the data using JMeter's built-in listeners or by exporting results to external tools like Apache JMeter's dashboard report. And then finally the ninth point, which is the scalability testing. So consider testing the application scalability by gradually increasing the load to determine at what point the performance degradation starts to fails. And then finally the parameterized test data. So we have to ensure that we have a wide range of products, user profiles, and cart contents to avoid cache related performance optimizations and ensure comprehensive testing. So these are the points that we have to cover when we were asked that how are we going to do a testing for a expected load of around 10,000 users. So now we will move on to the second question. So in the second scenario, the interviewer is asking you that you need to perform a distributed load test for a social media platform. So you have your client who is actually a social media platform, and your interviewer might want you to perform a distributed load test for the social media platform. So the system is expected to handle 1 million concurrent users who are spread across multiple geographical locations. So which means you'll have to test the CDN, which is the content delivery network, which is actually local to all the geography. So now you have to explain how would you set up a distributed load testing environment using JMeter. So if this scenario is being asked for a near load or for load generator, the answer would be completely different. But for JMeter, that's totally different because the way it has to test is completely different when compared to the other tools. So what considerations would you take into account to ensure accurate load distribution and synchronization among the JMeter instances? So apart from testing, here the main point is the load distribution and how do you sync among the JMeter instances. So let's now go to the answer. So this basically deals with the distributed load testing for the social media platform. So the very first thing which you have to do is the test plan design. So you have to design your test plan in JMeter, including the thread groups, the samplers, the controllers, timers, and other elements as required for simulating your user behavior. So you have to plan all these elements, the thread groups, the samplers that you're going to use for testing, the controllers, the timers, and any other test elements which are required for simulating the user behavior. And the second point here is we have to set up the distributed testing. So how will you do the setting up of distributed testing? So the first point is you have to set up a master slave configuration. So JMeter's distributed testing works on a master slave architecture. So one machine, the master, controls and coordinates the execution of multiple machines, which we normally call as slaves, which runs the JMeter. And the next thing is the network configuration. So we have to ensure that all machines starting from the master to the slave are on the same network and they have to communicate with each other, and this can be a local network or a virtual private network setup, which we normally call as the VPN. And then the third point here is the same JMeter version. So this is very important because most of the times people might be using different JMeter version in different machines, and they might be raising a bug or asking questions that why I cannot connect as part of the distributed testing. So we have to make sure that we use all the machines with the same JMeter version. So we have to use the same version of JMeter on all machines to avoid the compatibility issues. And then coming back to the next point, which is the distributing of test plan. So we have to copy the test plan. So we have to copy our test plan, that is the JMX file, to all these slave machines, and each slave will execute the same test plan simultaneously. And then when coming back to the thread group adjustments, in the thread group we have to set the number of threads and ramp up time to suit the distributed scenario. So the total number of threads across all slaves should match the desired concurrency level, that is the, in this example is 1 million users. And then the next point is the load distribution and synchronization. So we have to first do a user breakdown. So we have to divide the total user count among these slaves. For example, if I have 10 slaves, each might simulate 100,000 users. So in this way I can divide the total user count among these slaves. And then coming back to the next point, which is the IP spoofing. So I have to ensure that each slave machine is assigned a different IP address to mimic the users from different geographical locations. So I have to use network tools or VPNs to achieve this. And then coming back to the next point, which is the global configuration. So I have to use JMeter's remote start all option in the master's GUI to trigger the test execution on all slaves simultaneously. So after I do all these global configuration settings, I have to move to the next point, which is the aggregate report listener, where I use the aggregate report listener in JMeter to collect and consolidate results from all slave machines. So this provides a comprehensive view of the overall performance. And the next point is the synchronization mechanism. So the timers. So how do you synchronize the test? So the first point is the timer, where I use synchronization timer elements to ensure coordinated actions across different slave instances. So for instance, I introduce a synchronization point before a crucial user action such as logging in or posting a comment. Then the next point is the think time adjustment. So I have to adjust the think times for different geographical regions, as users from various locations might have different browsing behaviors. And coming back to the next point which we have to cover is the results analysis. So far we have did all the planning, we did all the distribution, and we do all the synchronization mechanisms, and the test is completed. So the next point is the result analysis. So we have the aggregated results, where we have to collect the results from all the slaves and analyze them together to get an accurate picture of the platform's performance across geographical locations. The next point is the response time variation. So we have to observe any variations in response times based on geographic distribution, and this can help identify potential performance disparities. And coming back to the next point, which is the scalability testing. So we have to test the system's ability to scale by gradually increasing the number of slaves or threads to see how the platform handles higher loads. Then coming back to the next point, which is the consideration. So what are all the factors that we have to consider? So the first thing is the hardware resources. So we have to ensure that each slave machine has sufficient resources, which is the CPU, its memory, its network. And why do we need all this? So these has to be or these we need to handle the allocated load. And next point is the data consistency. So if our test data involves database updates, we have to ensure that data consistency is maintained, especially in the distributed testing. Then the next point is the network latency. So we have to be accountable for any potential network latency between the master and slave machines, as it can affect the synchronization. And finally, the reporting. So we have to use JMeter's built-in listeners and reporting tools to generate aggregated performance reports for analysis. And distributed load testing allows us to simulate real-world scenarios more accurately with the potential challenges of geographic distribution and synchronization. So by following all these steps and considering the mentioned aspects, we can effectively conduct a distributed load test for social media platform. So now we will move to the next question. So now we will discuss the last scenario of this video. So in this scenario, you are supposed to do a API testing. So he give you more information about that. That is, you are responsible for testing the performance of a mobile application's backend API. So nowadays, every application is being communicating through API. So API testing is again a major or a critical thing that we have to do. We have to test again. So the APIs handle user authentication, and it retrieves the user profiles and posting comments. So these are the three actions of the transactions that the APIs do. That is, handling the user authentication, retrieving user profiles, and posting comments. So how would you create an API testing scenario in JMeter? And you have to describe how you would set up the necessary HTTP request, and how will you handle authentication, and how will you validate the API responses for correctness and performance. So now we will see the answer for this scenario, which is the API testing scenario. So the very first point is, in every testing, so setting up the proper test plan is the very basic thing that you have to do, or the very first thing we have to do. So the very first thing is we have to do a test plan setup. So the second point is the thread group configuration. So what is the difference here compared to the other scenarios that we have tested? So in this scenario, we have to add the thread group to simulate the number of users who make the API request, and we have to set the number of threads and ramp up to simulate the realistic user load. And then coming back to the third point, which is the HTTP request. So for each API endpoint, that is the three transactions we discussed in the previous slide, that is the user authentication or user profiles or posting comments. So we have to create each API endpoint, and we have to add a HTTP request sampler. Then coming back to the fourth activity, which is the handling authentication. So if the APIs require authentication, we will need to deal with tokens or headers, and here is how we can handle it. So for the very first scenario, we have to log into the request, where we create a HTTP request sampler for the user authentication endpoint, and we have to set the method to post and provide necessary parameters. And the second transaction has to be extracting the token. So we have to use a JSON or a regular expression extractor to capture the authentication token from the response, and this token will be used in subsequent requests. And thirdly, we have to add a token to request. So for subsequent requests, we have to add the extracted token to the authorization header. And then the next point is the parameterization and data variation. So here, for user profiles and comment posting, we might want to parameterize the data to create variety. So we have to use CSV dataset config to provide different data for each thread. And then the next point that we have to cover is, how are we going to validate the API responses? So we all know We have created a test plan, we have set up the thread group. So how, and we do all sort of testing and creating the script. So how are we going to validate the response, whether we are getting the actual expected response? So user assertions is the primary factor that we use to validate the correctness of API responses. So for that we use the response code assertion, where we will add a response assertion to verify that the response code is as expected. So what is the expected response code, which is the 200 OK is the response code. So in fact we have different other response codes, something like 400 or 404 or 500 or 503. They were the response codes which tells us that there is some issues in the application or in the server, but the actual or the expected response code is the 200 OK. And then the next assertion is the JSON assertions, where we use JSON path assertions to verify specific values within the JSON response. And then coming back to the next factor, which is the performance testing consideration. So we have to test performance based on few scenarios, which is the response time. So for the APIs, we have to add a response time assertion to ensure that the API responses meet performance expectations. And coming back to timers, we have to introduce the think time between the requests to simulate user pacing and test the server load under realistic conditions. And then coming back to the third performance testing scenario, where we have to use the constant throughput timer, which we will use this timer to control the rate of request, which simulates the steady load. And then coming back to the next factor, which is the results collection analysis. So far we created a HTTP request, we handled the authentication, we did the parameterization, we validated the response, we did all the performance testing considerations. And coming back to the next point, which is the result collection and analysis. So we have to configure the JMeter to save the test results using listeners like aggregate report or the summary report or view results tree. And then we have the ramp up and load testing, where we adjust the ramp up time and thread count in the thread group to simulate different user in the result collection analysis. So we have to configure the JMeter to save the test results using the listeners, so which we discussed earlier. And then the next point is the ramp up and load testing. So we have to adjust the ramp up time and the thread count in the thread group to simulate different user load scenarios. And coming back to the next point, which is the error handling, where we have to use the post processors to extract the error messages from API responses if needed. And then the next point is the assertions for performance. So in addition to correctness assertions, we have to add assertions to monitor the response times or throughput to ensure the performance metrics are met. And then next comes the distributed testing. So if we are testing at scale, we have to consider the distributing the load across multiple JMeter instances using the distributed testing capabilities of JMeter. And finally, we have the reporting, where we use the JMeter's built-in reporting tools or export results for further analysis in tools like Apache JMeter's dashboard report. So by following all these steps and considerations, we can create a comprehensive API testing scenario in JMeter, which covers the user authentication, user profiles retrieval, and comment posting, while ensuring the correctness and performance are thoroughly tested. So with that, I come to an end. We will discuss some of the other scenario questions in our next video. Until then, it's bye bye from us and Shanmugam and Little's Law.